Welcome and hello. This is a update video in HMS, and in this video we're going to be talking about specified values for gridded parameterization. That is a new feature in HMS 4.13, which I have on the screen here. This is the release notes. This page right here is the first link in the video description, and the feature we're going to be talking about here is this first one that's described, specified values gridded parameterization. If you scroll down just a little bit, here are a couple links. This is the tutorial right here, which is the second link in the description of this video, which is the tutorial. That's what we're going to be using to guide this video. And then the other link right here is a quarterly webinar, so you're welcome to watch that as well. They talk about a few other things, so I decided to make this video to only talk about this one new feature and follow this tutorial. Okay? So go ahead and click on the second link. It'll take you to this page right here, and we're going to go ahead and get started. The first step is to download the source data. These are the initial files, so just go ahead and click on this link here, okay? And then click on the download link, and then let that download. It's downloading to my desktop right now. All right, that finished up downloading. Here is the zip file. See what we have here. I'll open up this zip file. It opened up right here. Here is the project files, okay? I'm going to go up a level and then just move this punks directory into my project directory, a more permanent location where I want to save files. All right, so that's good to go. We can now close this directory. We don't need the zip file anymore. It's unzipped. Now let's open up HMS version 4.13 and then open up that watershed. So File, Open, then Browse. Here is the project directory, punks, and then click on punks.hms and select. All right, so let's open up the basin map here. Good to see this basin once again. All right, so what we have here is our three different subbasins. And over here in the components editor, we have the data for those subbasins. So with this EB Mahoney Creek subbasin selected, notice that we're using a discretization method structured. And if I click on discretization, we have the data about the projection and the cell size. All right, so we're ready to start on task one here. If we go back to the subbasin tab here, our loss method, which is what we're going to be focusing on in this video here, is the gridded deficit and constant selection. So if I click on loss, now we have an initial deficit type and an initial deficit grid and an initial deficit ratio. This is different than 4.12 and earlier versions of HMS because we didn't have this initial deficit type. We just had the grid and the ratio. Now, state is sort of what we're used to. That's by assigning a specific grid. But our new option here is specified values. So we're going to see what that looks like a little bit later. If you want to see 4.12, here's an example. I'm selecting a subbasin. I'm selecting loss. And then now we have the initial deficit grid, the initial deficit ratio. And then the other three parameters here are maximum deficit, constant rate, and impervious. Those are the four grids. Here are the four ratios. But in 4.13, we have four grids, four ratios, and four types. The types, of course, are specified values and state grid. Now, the initial deficit and maximum deficit, and these four grids that we're looking at right here, these are all static grids. Specifically, one of them is percolation rate grid. That's the constant rate. And then two of them are deficit moisture type grids. And then the last one is the percent impervious grids. So these are static grids. These are not time series grids like the data you may expect to see for temperature or pressure or precipitation. So the user's manual does have a list of the types of grids that you can use for the gridded parameterization. And here is the list: gridded simple canopy, gridded simple surface, and then gridded, basically the four loss methods right here. So for instance, I could click on a subbasin and then for my canopy method, it says simple canopy, but I could also go to gridded simple canopy, and I would have the same parameterization options that I'm about to demonstrate for our loss method, which is gridded, deficit, and constant. Okay, I'm going to actually start on the task one now. What it says to do is to go to parameters and then menu, loss method right here, gridded, deficit, and constant. This brings up our global editor dialog box. Each row of this table is a subbasin, and then each column is a particular parameter. This is the same data we were looking at before, except now we can see all of the subbasins in the same view, not just one single subbasin at a time. Again, this first column here for the type is new, but then here's the grid, here's the scale. For maximum deficit, that's right here. Here's the grid type, here's the actual grid name, and then here's the scale. The tutorial asks us to make the same change for all 4 of these parameters, but just to keep things short and simple, I'm only going to do this exercise and demonstrate for the initial deficit. So just to compare with 4.12, if I go up to my loss method, gridded, deficit, and constant, let me just take the filter out, all elements. Here I just have 8 fields compared to the 12 fields I have there. So I have my 4 grids and then my 4 ratios. Again, that was 4.12. Now we have a field for type for each of our 4 grids. Also, what's new in 4.13 is this tab here for grid cells. So here's the subbasins tab. Here's the grid cells tab. Let me make this a little bit skinnier here. For each of the individual grids, we have a column for the subbasin, the I and J value, which is like an index, and then the values for initial deficit, max deficit, constant rate, and percent impervious. So we're actually seeing the static grid values right here in this table. That's new. Here in 4.12 down below here, we don't have those tabs like we do in 4.13. All right, we had the same filter, but we don't have the subbasin and grid tab. All right, so here is the grid tab. Since the type that we've selected for each of these 4 grids is state grid, these are static, they're not changing. These grid values right here are calculated, but they are read-only. They're not something we can edit directly. However, we can make edits if we go ahead and go back to subbasins. Like I said, I'm only going to be making changes here to initial deficit to sort of show how it works, but I'm going to change the state grid to specified values. And I'm going to do so for all 3 of the subbasins, specified values and specified values. When I come down here and click apply to save it, and then click on the grid cell tab, now voila, we have blank fields, values for us to input data. So I could just do manual edits like 1, 2, 3, 4. Not going to do that though. That's a little time consuming. Plus we have, I don't know, maybe 100 different grid cells. So this is where the global calculator, expression calculator, would be really helpful. So let's go ahead and do that. I'm going to click on calculator. And then up here for the field that I want to calculate, it's going to be initial deficit. That's correct. Maybe I just want to set it to 4 everywhere and click calculate. And then boom, 4 everywhere. That's not realistic though. So what I'm going to select here is the moisture deficit initial deficit. So just click down here in the expression editor and then double click moisture deficit, initial deficit. Moisture deficit is the type of grid. Initial deficit is the actual name of that grid. And then boom, here it is right here. If I click calculate, that'll give me the actual state grid values. But this is where we have the flexibility to use math and functions and other data to modify these values on a global scale. All right, so say for instance, I wanted to add half an inch to each of these values. This is the flexibility of the expression editor. So I'm just going to say plus 0.5, and then that would make 4.05, 4.55, 4.17 would become 4.67, and so on, all the way down for all of these cells. So that's the power of the expression calculator. I'll go ahead and click calculate, and just to check, yep, 4.55, 4.67, and so on. So let's go ahead and click close and then click apply to save that data. If you're curious where that data was saved, it was saved in a puxatawny.sqlite file in the project directory. So I'm going to investigate that real quick. And keep in mind, I'm looking for 711-1059 to confirm the initial deficit is 4.55. Here is my project directory. Here's the punks directory. And then I have a puxatawny.sqlite file right here. So I'm going to open that up in my SQLite Studio. And then I have a table for gridded, deficit, and constant. We'll go ahead and click on that, view the data, and then let's see, I need to find my fields here. I'll sort by I and J. So the I and J here, hold on a second. Okay, that's I. There's J. It's kind of hard for me to read. And then what I'm looking for is 711 and 1059. I know I could write a query, but there's not that many cells here. So 711, 1059, 4.55. Right, so very cool that those numbers have been changed. Now, if we were using specified values for those other grids, I assume that those values would be written in this same table, or at least in these fields right here, because this is maximum deficit, yep, constant rate, and impervious. All right. So gridded deficit constant, this is the name of the loss method that's associated for this particular basin. All right, the last part, this is we're done with task 2 now. Let's move on to task 3 if you're following along in the tutorial now. So let's see here. That was task 2. Task 3 is the last part, which is right here. Launch a global editor from the component editor. So back to HMS, I'm going to click apply, close that. Down here, if I select a subbasin, and then I click on the loss method in the component editor window. Let me make this a little bit wider here. All right, so now we have specified values is selected because we made that change in the global editor for our initial deficit. And then we have a file path to the SQLite file. See? And then the ratio is still 1. All right. For the other 3 grids, we've left them at state grid, and they just reference a specific grid that's already been loaded into our HMS. So if you wanted to change one of those state grids, you click this button right here, select the specific, what is this, a moisture deficit grid, I believe, and then click select. But if you wanted to update the specified values, then you can do that directly by clicking this button. It will open up the global editor for that particular method, the gridded deficit constant method, and it will also pre-select just the grids in the selected subbasin. So now I'm only seeing records for subbasin Punks Local. If I come up here and select a different subbasin like EB Mahoning Creek, and then I click on this button here, I'm only seeing the grids within EB Mahoning Creek. Here are the I and J values, and it also automatically selects the grid cells tab. So that's a nice touch there. But yeah, we're ready to make the edits right here directly into these cells, either manually or by using the expression calculator. Okay, well, that's it for this update video. We talked about the specified values for gridded parameterization. It's a new feature in HMS 4.13.